Hey, Marshall Ops Space Lab here. We're ready for discussions with the fluid physics module investigators. Go ahead.
Terrific, Byron. We're getting John Padday brought on active air-to-ground.
John Padday here, Byron.
Oh, John, read you loud and clear. Go ahead.
Good. Now, Byron, we have would like to clear the understanding before coming to the anti-spread. Can I just summarize how we understand the experiments that are going in all cases of liquid entry? First of all, the spreading on the front end plate goes beyond the anti-spread barrier prior to it jumping to the rear end plate. Is that correct or not?
Yeah, that's correct. It generally from the feeding end plate, it will jump over onto the anti-spread barrier.
Okay, copied that. Now, the next thing is, in the question of the liquid jumping from the front to the rear end plate, have we understood it clearly that this liquid actually jumps mechanically and stretches in the process?
No, the liquid does not jump from one to the other, but
sorry,
yeah, the liquid does not jump. It forms a bubble, but for at least Isidoro's experiment, the bubble is too big and will spread over the feeding end plate prior to reaching contact with the rear end plate. Over.
Okay, I've understood that. Now, is spreading very strong on the rear end plate as soon as the liquid touches?
Yes, it's pretty rapid. It takes on the order of less than a second.
Okay, and when it does spread, does it go clearly beyond the anti-spread barrier of the rear end plate without any hesitation?
No, it doesn't. In fact, normally it attaches quite nicely to the rear end plate.
So what we have now is only the front end plate failing. Is that correct?
Well, up to a point. What happens, let me describe the last run that I just tried to do when we were out of contact. I was able to form a bridge, form a zone. I kept it somewhat concave, so it was a nodoid. It was not a catenoid yet. And I slowly increased the dimensions until I got to Isidoro's Point Lima. But before I got that far, the liquid had spread over the feeding end plate, so that now I had a nodoid of unequal base diameter.
Okay, I copied that. Now, the next thing is, in treating the end plate with anti-spread, you've done this several times now, and I was concerned about the amount of time given to it to dry before being approached with liquid silicone. Could you say how long you allowed the anti-spread to dry?
Well, on the end plate that I did, the 40 millimeter end plate, which was the front end plate, I let it dry overnight. I put it on last night, and it hadn't been used, I don't think, until this morning.
Okay, excellent. Now, the next thing is it possible for you to indicate at the handover all this to Ulf Merbold?
Oh, I'll try my best, sure.
Now, the main problems, we want to come to the donut problem. We believe we understand this. This presumably is only formed when the liquid is withdrawn and a dimple at first is formed in the upper surface above the entrance or exit hole to the reservoir. Is that correct?
Correct.
Okay, so we have now problems of a very flat drop. The most crucial experiment now is to withdraw the FPM from the rack, withdraw the carriage, and manually just put a small amount of liquid onto the end plate to see what it does. By small, I mean 2 to 5 cc's. when you have stopped feeding manually, does the liquid go on spreading? And is it possible to do that experiment?
Yes, I'll do it right now. Stand by. I'm right here.
Byron, could you go into mumble mode and watch the contact angle particularly, please?
Okay, well, I put about 1 or 2 cc's in, and I stopped, and the liquid spread out about 2/3 of the way across the 40 millimeter front plate. And now it's slowly spreading, very slowly spreading now. It's out about 3/4 of the way.
Is the contact angle 10, 20, or 30 degrees at the moment, please?
Oh, it's very difficult to say. I'd say it's under 10 degrees.
Excellent. We're getting somewhere very quickly. Is it over the anti-spread area yet?
Negative.
And is the contact angle changing when it gets to the anti-spread area?
Yeah, I don't have enough fluid on yet. Stand by. Okay, now it's just touched the anti-spread or the edge of it. And it looks like it's holding with a contact angle of, I'd say, 10 to maybe 25 degrees.
Oh, that's splendid. Now, could you increase the volume by just a little, so that the height of the drop is no more than, well, half a centimeter. That's 5 millimeters.
Roger, it's in work.
Make sure
Okay, that's done.
that the drop height is no more than 5 millimeters.
Okay, that's complete.
Okay, is it holding at the anti-spread?
Yes, it is.
Excellent. Can you increase it a little more now? Just a little more,
Right.
to about 0.7, 0.8.
Okay, that's done.
Okay, now.
Still holding at the anti-spread barrier.
Excellent. Now, the next thing is we're going to go into the donut mode, but be very careful not to to pull gas in, or air, I should say. Could you now withdraw very slowly and see if you get a dimple?
Okay.
Do you get a dimple?
Looks like we're nighttime now and we're getting some good air glow, so I think I'm going to have to switch over and do one of the other time-critical experiments for a little bit.
Okay, look, Byron, that's superb. You've really helped us along a great deal. Thank you very much. I suggest you wipe off and close when possible.
Okay.
Space Lab, this is CPAC on Air to Ground 1 for Byron.
Go ahead, Bill.
Thanks. I'm wondering if maybe we're in a good altitude so that we might pick up some air glow with the MTV. Do you have a feeling for that?
We're looking at it. Looking at air glow with Appy right now, and just about ready to get cranked up on the MTV.
How about vehicle glow?
To check that with the MTV. And a question for Steve, if he is on the line here. I've rolled up FO4 contamination, and I'm just cycling through the various filters of interest to air glow. Does he have any other suggestions? Over.
This is Experiment 3 Space Lab. We have been getting some digital real-time data, and we have seen that you just scanned through the air glow layer, and you were cycling through different filters. Is that correct one?
That's correct, Steve. Do you have any other suggestions?
I believe you are pointing a little too far up now. I would go into 6300 filter, and perhaps if you have sunlight on the horizon, maybe you should use the 2800 filter for the TV and for the PCA as well, if you are getting near to a terminator. Otherwise, 6300 should be your high altitude best bet.
Okay, I've cycled through several filters already, and we do have sunlight on the horizon. Maybe a little later in the night it'll get darker, but we also have to share this one television, video display, so we'll be going back and forth between MTV and Appy in order to get our filters and pointing correct.
And Space Lab will have to caution you that you'll have to manage your own recorders, since we can't do that from the ground. For anything that you can't send down to us, so you need to record.
They're coming on right now, Mike. Thank you.
Thank you, Owen.
This is Experiment 3, Space Lab. Are you saying that you are sharing monitors with another experiment?
That's right, with the MTV. We only have the one monitor.
Okay, be very careful of not letting the API saturate or do something that. This is the 2800 filter now, is that right?
That's correct. That's what I got.
Oh, yeah, that's...
Beg your pardon. I got 3914 in now.
What about a PCA, Owen?
PCA is in 2800.
Yeah, that's beautiful. We can see the magnesium on one side and the lack of the darkness on the other. Very beautiful.
Okay, I think I'll go ahead and cycle them and get you some others now.
Okay.
Steve, are you guys getting real-time data down there?
Absolutely.
Yeah, we are good.
Good data flow, Byron.
Okay, so you got video data going down to API?
Negative.
Oh, okay, it's just the analog data, okay. Picture looks pretty good there too, Steve. 2200.
This is 6300.
7200 OH, and only on high voltage step 1, so it's pretty bright.
Okay, we don't see the TV. All we see is the PCA data, and you must be still in the 2800 filter pair. It's probably a good move to stay there.
Happy, do you have any real time of the monitor now?
We have real-time data, yes, Owen.
Okay, take a look at 3914, 2800 here. It is really a much stranger geometry than any of the other lines. So it's possible that magnesium there has some different structural alignment.
Oh, that's beautiful. That's beautiful. Now, our data here is the PCA data only, and that is wasn't the 2800 filter, I don't believe. Oh, there it is. There it is. Thank you. That is looking beautiful. That's 2800 data, definitely. And
Never seen that kind of a structure, Ed?
We cannot see the structure one. All we have is the 10 by 10 photometer, and all we can see is that you have got definitely 2800 and no contamination on the other side, because it's a two-channel photometer.
Okay, well, there's a lot of structure here that is not visible on any of the other wavelengths.
Beautiful. I hope you got your tape recorder running.
We do, and some of it is at substantially higher altitudes. I would guess a couple 100 kilometers.
Very nice data. Great.
Marshall Ops, Space Lab.
Go ahead, Byron.
Okay, Michael, we've got some really good API data. We haven't been able to see much of this from the CPAC MTV. With their concurrence, we'd like to switch over and record API on recorder number 2. We've only got about 3 minutes left on recorder number 1, and we'd like to use some of the MTV time on recorder 2.
Sounds like a good idea. Let's let API and CPAC talk about that and tell you what their answer is.
Okay.
By the way, the Experiment 20 electron accelerator will start emitting at 06 hours, 11 minutes, about 5 minutes from now.
Okay. Okay, so then we want to be back on MTV, I think.
Yeah, I guess so. Let's see what CPAC and API say about that. By the way, they also suggest that the best angle at which you might see the beam itself is that zero co-elevation, that is straight out the minus Z bay.
Okay, we copy.
This is Experiment 3. It appears that CPAC would like to have the TV monitor, the video recorder and we are discussing it, and they were saying that they would like to go over to it at 6:10:30. They would like to over and use the videotape recorder. Right now we should have...
Okay, we copy that.
We should keep having the videotape recorder right now.
Okay, very good.
Space Lab, this is CPAC on Air to Ground 1 for Byron.
Roger, go ahead, Bill.
When you have time, if you could just bring the MTV down towards the Space Lab module so that a very small portion of it is visible in the picture, then we will have a reference point for the beam.
Roger, welcome.
And Byron, if you'd like us to do the video rerouting or changeover, we can take care of that from the ground. We have command capability.
This is experiment.
Okay, Mike.
Byron, did you want us
I
to...
guess what we'd like you to do is set up VTR number 2 now for the MTV. We're going to go ahead and switch over here.
Okay, Byron, thanks a lot. We see you've switched over there. And we have both tape
And
recorders.
we'd like you to...
Did you want us to do it?
Okay, we'd like you... Yeah, we'd like you guys to reconfigure the video analog switch to put MTV back on recorder 2 now, please.
Okay, will do.
Okay, number 2 is running.
The electron accelerator has started firing now.
Okay, very good. Well, I've got MTV turned on. I've got the top of the module in sight. I don't know if it's scintillation of the tube, but I've got a lot of little dots up here. It's hard to tell. It's constant, so I don't think that shows the beam. We got all kinds of RAW and IO messages again, Marshall. I'm not seeing anything at all with PICFAB.
And Space Lab, this is Marshall Ops. We have, this is a string of brief pulses from experiment 20. Duration is extremely brief, but there are 8 of these pulses per second.
Okay. Unfortunately, we're not seeing a thing, Mike.
Yeah, we copy.
And nothing is obvious visually out the back window.
Space Lab, this is CPAC on Air to Ground 1 for Byron.
All right, you go ahead, Bill. Loud and clear.
What do you see in the MTV monitor now, Byron?
I've got the top edge of the Space Lab, and I'm moving a little bit to port, but I don't see anything at all, to be honest with you.
Are you at maximum sensitivity? Iris open?
I've got the iris in auto, and the sensitivity is in high gain, and it's close to max.
Very good. Byron, do you see a star background?
All right, that's affirmative. Good star background. We got a lot of scintillation now, and I've got the sensitivity up at max.
Very good.
This is experiment 3 to Owen. Would it be possible to read some camera temperatures when you have a moment from line 4 on the video monitor?
Yes, in just a moment when they're through with the MTV, if you can wait. And I've already put the instrument to stop and high voltage inhibit because we're right at sunrise here. So I'll read you some temperatures in just a moment.
That's fine, no hurry.
And Space Lab, this is Marshall Ops. Be advised that we have VITR number 1 in rewind. You may hear some funny noises coming out of it. That's the reason.
Okay, thank you, Mike. And how much more do we have on this 20 pass? Are they still firing?
Space Lab, this is CPAC. Byron, feel free to terminate now.
Okay, we'll go.
And thanks very much for your operations this time.
Roger, sorry about that. We didn't see a thing. And I pointed from the top of the space lab pad left and right, and then even tilted up to try and get a higher co-elevation. Not a thing.
We'll process the devil out of it later.
Okay, guys, good run. Thanks very much. We're going to be playing this data back on the very next rev and have a look at it ourselves.
Okay. Steve, do these, how many of these temperatures do you want to cycle through here?
I'd like the last 12 to 15. Thank you, on.
Okay, I guess these numbers as they come up are the ones you want. Plus 16, 30.
Okay, I copy.
Plus 16, 10. 01 is the ID, minus 49. Double lot, minus 49. The ID 15 is plus 23. 13 is plus 24. 15 is plus 10. 12 is plus 14. 11 is plus 19. 10 plus 22. 09 is minus 49. Is that enough?
That's affirmative. Thank you.
Okay, and Marshall Ops Space Lab PS2 here. If John Taday's around, I think if we have some more coverage, I can give you a couple more minutes of FPM here before we go LOS.
Let's see if we can find John.
I'm on the loop. May I go ahead?
Very good, John.
Thank you. Byron,
Okay.
we're really getting on splendidly. Can you just complete by increasing manually the volume on that front end plate with the thing open until it just starts spreading, and give in mumble mode the height of the drop and the angle of contact? If you can do that, we're...
Okay, John. Okay, that's in work now. I tried to form a dimple, and the only thing that forms a dimple is really retracting the liquid in a hurry, at which time it sticks onto the edge of the feeding plate.
Sorry, you've misunderstood. Can you increase the volume, not decrease?
And I'm increasing it now. I just thought you wanted to try and form a dimple before.
Okay, fine. The dimple
Okay.
works.
Okay, very good. I've got about 1 centimeter now. Maximum height on the bubble. It's still attached. Contact angle looks like 40 degrees. There's 1.5 centimeters. Contact angle 45 degrees.
Splendid. You can close now unless you want to go a little further. Don't go further than 60 if it will take it.
.5 centimeters. Contact angle about 60 degrees. It's still staying attached to the 40 millimeter disc.
I'm copying this as you go, Byron. Don't go above 60, please.
I'm going to be bringing the fluid back in now. Do we still have you, Marshal Ops?
I'm still on.
Go ahead.
Okay, very good. What do you want to do next, John?
Okay. I'd like you to go actually to 75 if you can still do it.
Yes? Okay, it's in work.
Okay, you can start withdrawing now.
I haven't reached 75 yet. I was already withdrawing. Here comes some more out. Okay, it looks like we can reach 75 degrees.
I'm copying you, Byron.
Okay, very good. I'm at 75 degrees now.
Do you think it will take up to 90? Try it.
I don't know.
Try it, but be ready to withdraw manually if there's the slightest chance of it going too fast.
too late. I didn't quite get to 90. I got to about 80, a little over 80 degrees, and it spilled over the edge.
Okay, can you go up to 90, please?
Couldn't get 90, John. I got about 80 or so.
Then what happened? Did it race over?
Yes, it did. It's gone over asymmetrically onto the anti-spreading barrier.
Okay, can you withdraw the liquid now then, please?
Roger, I'm doing that.
Space Lab, this is Houston, air to ground 1.
Okay, Houston Space Lab, go ahead.
Roger, just wanted to let you know that we got the patches in okay in 2 stages. You got the self-test messages. We think Route 21 is now good for serial data.
Okay, Murray, I understood Route 21 good for serial data, and the other was, you say the patch that you were working on is now in and good?
That's correct. The patches are now in and good.
Okay, sounds better.
We'll give you back to the guys in the back now.
Okay.
Can I go ahead, please?
Go ahead, John.
Baron, the next thing is we would like to ask you a few questions about the movement of the reservoir. Is it jerky? Is the front end plate movement jerky?
Sorry, say again, please?
Is it
John, I didn't
jerky?
copy. Say again, please?
Is the movement of the front end plate and reservoir at all jerky or juddery?
No, I don't believe it is. I believe it's smooth, but even at the 0.1 millimeter per second speed, it injects fluid extremely rapidly, and the fluid bounces all over. It's really just barely on the limits of stability.
So what you're saying is that the feed rate is far too high and is designed too high to get the liquid out reasonably without spitting.
That's affirmative.
And we'll see.
I think the highest...
We'll see at 6 plus 45.
Very good.
And
I will be in work.
And we'll have John some more.
Columbia, this is Houston with you through Yargity for 7 minutes. Columbia, this is Houston with you through Yargity for 7 minutes.
Let's see, got anything to go up? I found it. I believe this is it. And Space Lab, this is Marshall Ops. We have you for about 6 minutes at Guam.
Okay, Bill, got a good copy. I'm in the middle of doing 25.
Okay, Roger. And we have Dr. Helen Ross, who would like to talk with you on the next pass and debrief with you.
Okay. We all have one unanimous input so far that it's pretty difficult to do this in space.
Okay, we copy.
Marshall Ops, Space Lab.
Go ahead.
I'll give you one quick thing on ISO. When I went back to the ISO panel at 6 hours 30 minutes to initiate the FO-14 modifier 87, the FO running way was still on from the 1689 combination. And that sounded kind of screwy because that should only run about 90 seconds or so. So I reset in the new FO and modifier numbers and hit start. The running way went to standby for several seconds and went back to run. It's now in standby, over.
Okay, we copy. You're now in standby.
Yeah, thanks for that readback, Bern. I'm going to check with experiment 1. That sounds a little bit off nominal to me, but I want to see what Marcia says.
Kid, it sounds off nominal to me.
And Space Lab for Owen.
Go ahead, Bill.
Yes, after you finished 335, we have a procedural change to the ECOS crash recovery procedures. We'd like to uplink when you have a chance to copy.
Okay, I have let me see, 335. Oh, okay, that's completed, Byron says, and so go ahead, I'm ready to copy.
Okay, we'd like to make a modification to the procedure on page 4-Echo, page 9-9. Correction, 9-19er.
Oh?
Okay, we want you to wait until Sierra 99X01 is in hold. And we want you to do that before you go to step 1.
Okay, which book?
And let me give you the rest of this copy. We want you to wait until Sierra 99 Yankee 02 is in hold before you go to step 2. And it is in the CDMS dictionary. And it's on page 9-19 in the CDMS dictionary.
Okay, you were cutting out partly there. I believe the only thing I missed is before step 2, it's Sierra 99. I missed the next letter, 02.
That's X-ray.
Okay, Sierra 99 X-ray 02.
Negative. Sierra 99. The first one we gave you, Owen, was Sierra 99 X-ray 01. And the second one we gave you was Sierra 99 Yankee 02.
Okay, I copy.
Okay, we've got you for about 23 seconds, and we'll see you in about 13 minutes at 7+05 with S-band.
Sure.
And Space Lab Marshal Ops, we've got you on S-band for 49 minutes.
Okay, Bill. Loud and clear, Bill, and I'm finished with 25.
Okay, we have the PI standing by to talk with you.
Roger, loud and clear, 025 PI. Hi, Alan.
Hi, I'd like to thank you for performing the experiment 025, the mass discrimination, and reading out the data for the last performance. This showed that you are nearly adapted back to the baseline level, and I wonder if you could tell me, did it feel much more difficult than on the ground, or was it nearly as easy?
No, it's much more difficult. We all think we have a much harder time of determining which is heavier up here.
Well, that's very interesting to know. I wonder if you could tell me if this round that you've just done was any easier than last time.
Oh, it feels about the same. Owen estimated also that only about 20 to 30% of them did he feel confident that judge which one was more massive.
And how about you? Did you feel your run was any better or not?
I really didn't. I'm sitting here with the card if you want the letters.
I'll find out later. Could you answer me another question? I'd like to know how your own body weight feels. When you first went into zero gravity, I expect you felt very light. Do you still feel very light, or are you getting more back to normal?
No, I still feel like I'm really, initially felt like I was totally upside down. I have the feeling that I'm always trying to float up to the ceiling, even though really not.
Uh-huh. And how about objects that you move around? Do they feel very light, or do they begin to feel more like normal objects?
They feel more like normal objects. If it's something pretty massive, it just takes a lot of attention, and you have to be very slow to move it over.
Thank you, that's very interesting. Is there anything you'd like to ask me?
No, I don't think so. I want to apologize for not getting to your experiment the first day. It was extremely hectic up here, and we were just really coming up on the learning curve and got way behind schedule.
I quite understand that. If you get a chance to read out the results of the experiment you've just done, that would be very helpful to me.
Okay, I'm ready right now if you are.
Right, I have sheets just in front of me if you could tell me which number the card is.
Card number 7.
Okay, I have it in front of me.
Okay, I'll read them out one column at a time without stopping. Number 1 is Tango, Charlie, Hotel, Uniform, Kilo, Lima, X-Ray, Quebec, Juliet, Tango, Quebec, Golf, Alpha, Tango, Charlie, Victor, Golf, X-Ray. I'll copy over.
I have that.
Okay, column 2. Lima, Foxtrot, Golf, Quebec, Charlie, Charlie, Tango, Kilo, Alpha, Lima, X-Ray, Mike, Golf, Foxtrot, Sierra, X-Ray, Lima, Hotel. I'll copy over.
I have that too.
Column 3. Tango, Charlie, Lima, Lima, X-Ray, Lima, Golf, Mike, Charlie, Mike, Echo, Tango, Mike, Whiskey, X-Ray, Mike, X-Ray, Mike. I'll copy over.
Break. Byron, we need an OP on Route 20.
Mike, you know about that message we got just as you went over the hill last time?
What was that message?
Route skipped 20, which is, of course, the reason
Right.
you need to have a re-op.
Yeah, we see it. And thank you very much.
Again, Mike.
Thank you very much, Byron. We see it. Thank you.
Okay, Okay, back to the 025 CI.
I copy.
Okay, column 4. Quebec. X-ray. Excuse me, Echo. Romeo. Lima. Kilo. Sierra. Charlie. Tango. Delta. Lima. November. Golf. Papa. X-ray. Romeo. Mike. Golf. X-ray. How copy, over?
I copy. I read you loud and clear. The total list is now complete. Thank you very much.
Hey, Roger, you're welcome. Good afternoon down there.
Good afternoon.
Space Lab, this is Marshall Ops. We need someone to place the Experiment 1 auto manual switch in the auto position, please, right now. Thank you.
Complete.
Also, we'd like a front panel status, switches and lights, for the Experiment 1 front panel.
Okay. All three depth, spec, cooler power lights are on. Auto, FO ready light on. High voltage enabled, and the mode selected auto.
Thank you very much.
Space Lab for Byron, this is 102.
Roger, 102. Hi, Larry, go ahead.
Hello, Byron. First, could you confirm when you take out the bungees that the bungee strap adjustments have not been changed, and let us know after the dome experiment?
Okay.
Next, Byron, we're really very interested in what the result that seems to show that with the presence of bungees, all of you feel a very limited sense of circumvection. And we would like you and Owen to pay particular attention to it again on this run and give us a good qualitative report. You realize the scientific significance, I'm sure. Space Lab Byron, this is 102, do you copy? Space Lab for Byron, this is 102. How copy?
Loud and clear, go ahead.
Did you copy my last question and comment about the effect of the bungee cords?
Roger, that's affirmative. We did copy, and we'll pay particular attention to it.
Right. And next, we would like as much of an evaluation as you can give us once again on the contact lens sticking. I expect Dr. Thornton to be over, and we're trying to see whether there were differences between the experience we have now and his experience on STS-9.
Okay, will do.
That's about all I have, Byron, except to say that it's clear that the TV substitution appears to be a very good workaround. I would like your opinion on whether we should continue to try to go back and forth between split screen and single screen, or whether we should stay with split screen.
Larry, I think we'd be better off with a single screen, because I'm afraid it's just too difficult to get everything lined up for the split screen, and it's very easy to end up bumping the camera and either getting it out of focus or out of adjustment, and therefore missing either the landmarks or the eyeball landmarks.
I copy that, Byron. The focus problem should be independent of whether it's split screen or a single view. Do you agree?
Broken up. It really isn't independent because you have to have a much more precise positioning of the camera, and sometimes it's kind of difficult with our current setup to get it aligned exactly right in the dome. If we can get a little more leeway on the positioning of the eye and the fiducial marks, it makes it a lot easier. Then the dome doesn't hit it over.
I copy that. As long as we get 2 or 3 of the free floats with split screen, then we can do the remainder of the mission with the single eye.
Okay. You mean 2 or 3 different sessions, or 2 or 3 people?
2 or 3 people, one session each, and then your comments on how far the feet are swinging.
You were broken. Say again your last part of your transmission.
All right, 102 repeating. I would like 2 or 3, preferably 4 different crew members, and in addition, observations about how far the legs swing during the free float dome runs.
Okay.
Very good, Byron. That's all I have for you. We look forward to seeing more of the good dome data, and I understand another PI would like to talk to you.
Okay, PS2 standing by. And while we're waiting here, Marshal Ops, how do you read the PS2?
Space Lab, this is Marshal Ops. We'd like someone to please command DPA RA20 Oscar Papa. Again, I'm afraid.
Come on. Now, Mike, while Owen's doing that, if you can copy for the 331 experiment, I figured I used approximately 700 frames of his 331 Alpha magazine, and I'm putting it back in the stowage drawer. So if you can log that and transmit it to him, I'd appreciate it. Thank you.
Okay, 700 frames of the Alpha camera.
Negative, of the Alpha magazine. It's on the Bravo camera.
Roger, Alpha mag on the Bravo camera.
You got the route skipped through as soon as I did it.
Roger, we copy that, Owen.
Space Lab for Byron, this is 102 again. Go. Space Lab for Byron, this is 102.
Go ahead.
Byron, a few other comments. Doug Watt would like to pass on the word that the quality of the FO5 data is outstanding, and we appreciate it. Next, Byron, thus far all the crew members have reported negative outlasting circuit of action following closing of the eyes. If you feel that there's any doubt about that result and would like to try it once again, once action has been firmly established, please feel free to go ahead and do it.
Okay, we'll give it a try. I'm pretty convinced. We'll do it again for you.
Okay, you know the problem as well as I do. Next, if you have any reason to change the protocol from the 1, 2, 3, 4, the way you did last time, please report it to us later.
102 from BS.
Go ahead, BS.
Okay, Larry, Owen and I think we've given you 2 dome runs with the split screen, so do you want this one just single shot full frame of the eyeball?
If you feel that the quality of the eyeball data is significantly improved by doing it single shot, go ahead and do that. Just let me know.
Okay. Yeah, I really think it is.
Okay, and would you let us know which eye is being photographed?
Roger. It'll be the left eye, I think.
Left eye for both you and Owen?
That's firm. That's the eye we used the last 2 runs, so I think we ought to stick with that one. And Larry, one thing you should be aware of, on my first dome run series, the left contact lens that I pulled out looked like it was very dried out and had some foreign objects on it, so I used the right lens in my left eye. But there has been the left eye on all of the Blue Shift dome runs.
Yeah, very good. For your information, your left eye and right eye lenses are identical.
Okay, I just saw a little R on one and an L on the other, so I didn't want you to get confused.
Okay, thanks a lot.
Space Lab, this is Marshal Operations for Byron.
Go ahead, Michael.
Yeah, when you have that GHF sample 318 installed, and if you have a few minutes, the 300 team would also like you to install the second gradient mode IHF sample, number 302. You think you can fit that in before the dome run?
Oh, we've just finished the GHF. The problem with the IHF is the grad ops light is still on. As you know, we didn't get that thing finally going until 3:28.
I see. Okay, thanks a lot. I didn't realize that it wasn't flashing yet.
Well, remember we were delayed a couple hours because of that temp problem.
Yeah, I'll check with 300 and see how long it ought to be. Space Lab, Marshal Ops. Yeah, the 300 team thinks it's just about cooked, and it will be starting to flash any time. And they just wanted to tell you that you are go to install that next IHF gradient mode sample number 302 whenever you have time, and it does start flashing.
Okay, copy. Marshal Ops, Space Lab here for the 102 PI.
Okay, stand by. We'll get him, Byron.
Space Lab Byron, this is 102.
Okay, sorry, got the harness out. It doesn't look like the bungees have slipped. If you guys think you saw some lower accelerations on your data, you probably did, because we found it pretty hard with all our gear on and everything to get it tightened down, and I think we probably ended up not having it quite as tight as Doug would have desired, but that's just the way it worked out.
Byron, no, there was no observation of any problem. It was just a confirmation.
Okay, no, they hadn't, but I know personally, I don't think that I got the harness tightened down as tight as he would like to have it.
Copy that. Byron, a related question about tightening. Do you find it necessary to tighten the strap on the ARU more than you did earlier in the mission?
Certainly not. In fact, I think I probably had it too tight, which gave me a headache for about the first 2 days during the mission.
Copy that.
And Marshal Ops, Space Lab. Marshal Operations, Space Lab.
Go ahead, Byron.
Roger, Bill. I don't think it's on my PCAP. Are we putting the dome data on one of the tape recorders?
Stand by. It's going on AV2, Byron.
Okay, copy, AV2.
Space Lab Marshal Ops, somebody free, we'd like to have you op Route 20 again.
Okay, Bill.
And Space Lab, this is Marshal Operations. We really appreciate the excellent pointing which Brewster has given to this last Faust exposure. We've been tracking that real careful, and believe that we've taken an extremely good photograph of the Andromeda Galaxy. Might thank Brewster for us if you get a chance.
Okay, excellent. Will do, Mike. And just after I hopped Route 20, I got a route skip again.
Roger, we expected that.
Okay, glad you did.
And we're going to want you to op it at least one more time for this pass. We'll let you know.
Okay, we're standing by. I'm standing by. And we have Owen in the dome now. To the first run for the 102 PI, I can report that his feet swung, maybe an inch or so at the most, but it looks like there's really no neck torsion right now.
We copy.
Okay, Byron, we'd like to have you op Route 20 again.
You got it.
Byron, this is 102. We're getting good dome data on the ground.
Okay, very good. We're getting excellent eyeball data up here. Very sharp focus.
And Owen seems to continue to indicate that large after effect in the opposite direction.
Okay. Yes, that's right. And I can see on the TV monitor red rotary saccades in his eye here.
Space Lab, this is 102. We're no longer getting data, so any commentary you can give us on status from here on out.
Okay, well, there isn't much to say except that it's very good. The start of the vection appears to be about a 1 inch or so swing of his feet, and kind of oscillates back and forth a little bit, so it's not really clear whether that's true neck torsion detection or it's just the fact that you really can't keep your body perfectly motionless up there.
Right. You don't see any specific pattern in the course of it.
That's a negative.
And Byron, is that position at 45 degrees out a good safe position far away from hitting any, the feet hitting any object?
You don't get 45 degrees out, Larry. We're actually about 8 or 10 inches away from the material science facility, but like I said, the drift is only an inch or so there's absolutely no problems hitting anything.
Copy that.
One comment for the next time we do this is to put a piece of Velcro on the box as well as the contact lenses inside.
We copy Velcro on the box for next time.
Okay, that's the end of the dome run 1. Larry, I think we'll go ahead and leave it set up, and I'll hop in and do it free floating also. It really is a major job to change the position of the camera in the dome.
That's fine. Go ahead. So you'll be doing 31. You'll be doing the 3400 series. Step.
That's time it'll be dome run 4. Firm.
Space Lab for Owen, this is 102.
Hey, Larry.
Owen, if you have time while getting ready, or during Byron's first run, we still have another 2.5 to 3 minutes for you to tell us about your reactions.
They were very similar to that on the ground. I would say about 40% saturation. So a little bit of self-rotation, but a lot of the dome rotation as well. And just about as similar as I could imagine, really.
I copy. I assume you're referring to the dome supine, is that correct?
Oh, I never noticed that much difference between vertical and supine. Maybe I'm not being sensitive enough about what to look for. But I give you 40% saturation in either orientation.
I copy. And what is the effect of the bungees? We'll ask you to comment on that in the next run, but you'll be LOS.
Okay.
Owen, I noticed that you continue to indicate that very strong after effect. I assume that you're feeling that as much as in the earlier two runs. Is that correct?
Stand by.
Space Lab for Owen, this is 102. We will be LOS in a minute. If you have comments, either give them to me now or save them and have you and Byron report after the dome runs are over.
Okay, I'm just getting him started and focused here. Report in a minute.
Space Lab, this is Marshall Operations. We confess that we've turned off your VITR number 2 by mistake, I think, and you should turn it on whenever you start to obtain data.
Okay, but VITR number 2 shows power on here.
Oh, power is on, that's true, but I believe it's in standby now. And if you want us to
put it to standby and I'll start it.
Oh, I see, okay. Whenever you're ready to record data, you can do it or we can handle it, whichever you like.
And Space Lab will see you at 8 plus 40.
Okay, Bill.
And Space Lab Marshal Ops, we've got you for about 50 minutes.
Yeah, Bill, we got the good contact with you. Just before you came up, we got a 23 shutter open message, but I just looked out the F window, and by golly, it's closed, tight as can be.
Okay, we understand, and we have the 101 PI standing by for some troubleshooting on his experiment, and then Larry Young for some debriefing after him.
Okay, stand by 1 sec. Yep, no doubt about it. 23 shutter is absolutely closed. Schon geschlossen.
X-101 to Space Lab. X-101 to Byron.
A little too soon either. Looks like we're going. Marshall, do you guys want me to do anything with the 23? On the PTC display, the shutter says open, but I don't believe it.
Okay, disregard until we let you know otherwise.
Okay.
And we're establishing direct voice comm from the 101 team. He'll give you some instructions concerning this troubleshooting on the HeFlex experiment. Go, 101.
X-101 to Byron. Do you read me? 101 to Space Lab, do you read?
Roger, experiment 101, reach loud and clear.
We have, as I understand it, got the orbiter video sync shut off to the 101 experiment. We feel that this is possibly the cause of some of our trouble.
We'll do that on your command.
We'd like you to step through certain things and make observations on the video monitor. First, would you push dark box and observe the monitor?
Okay, that's in work.
Yeah,
okay, and on the monitor, I have the same display.
Okay, then.
Roger, on the monitor.
Now press dark box.
Did you see what it was? 101, we cannot yet confirm the VCU is shut off. Okay, we just uplinked the command.
I've got a good display. Okay, I've got a good solid display now. No jittering at all.
Very good.
VCU is off.
And that means the video sync was off.
Correct.
Now, depress select left. Turn the dark box off. Turn the dark box off and depress select left. After the rotor stops, observe the video image. If necessary, you can press door release and open the door and position the module in front of the camera, if necessary. Do you read me? 101 to Byron, do you read me?
Stand by 101, we lost lock, I'll let you know.
Okay. Do you read me? 101 to Byron.
Okay, now we got you loud and clear, and as soon as you said that, the display cleared right up. It's good and stable now, over.
Okay, now turn the dark box off and press select left and observe the video image. If you have to open the door to position the module, that's fine. Press door release first.
Okay, stand by. Here we go. I've got a display now, and it's sort of out of focus, and it's very liney, but at least I can see something.
You have a module to look at there?
Affirmative.
All right, read the tape counter. Then close and lock the left rotor door and press start.
Okay, the tape counter is 5, 9, or 6.
Thank you, Byron.
Okay, you're welcome. Looks like it worked to solve the problem, huh?
So as far as the dark box is concerned, yes. We know what the problem was, I think. It confirmed our suspicions. Thanks for your cooperation. Over.
No problem, and looks like that particular plant I was looking at had a little dirt on it, Alan.
I read you.
And 101 and Space Lab, if you're done with that test, we're going to reestablish the video synchronization now.
Okay, we're finished.
Space Lab, this is 102. Do you copy?
All right, you read your line clear. 102 PI. Go ahead, Larry.
Okay, Byron, I've got a few quick questions. Tell me which dome runs were done and in which order, please.
Okay, we did dome runs 1, 4, 2, 3.
Very good. Copy 1423. Next question, contact lens sticking and how to irrigate. Any comments?
Roger. The first run, it was sticky but not stuck. And Owen looked at it, the TV, and could confirm that it did not slip. It was negative slippage between the lens and the eyeball landmarks. I played around with it a little bit while Owen was in the dome, and I was able to get it stuck quite nicely, but only for about 2 minutes at a time, and then it would start loosening up. Over.
Roger, please put that in your logbook. We'll discuss it post-flight. Next, do you think that the TV focus is significantly better or easier with a split screen, and do you recommend that we stay with that?
Oh, it's easier to position the camera and see not only the eyeball but also the fiducial landmarks with only one camera. I didn't see very much postural swaying. I felt a little bit when I was in the dome, but Owen didn't remark about it at all. So, I don't know, I'd have to say if we want to make sure we get any eyeball...
Space Lab, this is 102. You cut out after saying if we want to get an eyeball. I assume you want to stay with a single screen, and I concur. Space Lab, this is 102. Copy.
Roger, go ahead.
Yes, we lost S-band after you said that there was no postural swaying, and I assume that you want to recommend that we stay with single screen, and I concur. Do you copy?
There's a significant counter-rolling, probably due to the semicircular canals. Over.
Say again. Well, say again on last.
Okay, I was able to observe my eye in the mirror, and while doing rapid head roll, was able to observe significant ocular counter-rolling, probably due to the semicircular canals. Over.
Very good, thanks. Tell me, do the bungee cords create a sensation of a phantom vertical when you're using them?
Well, I'm not sure what to say. It feels like you're standing up, really. I don't get any sense of the paradoxical vection. I don't get any tilt sensation. It just feels like you're tied down to something, and when you start rotating, everything is rotating with you.
I copy. We're out of time. Get back to you later.
Goodbye.
And Space Lab, we have the 201 PI standing by.
Space Lab, this is 201. Do you read me?
Roger, read you loud and clear, Jim. It'll be a while before we get set up here, so we'll get back to you.
Oh. Byron, we have some comments to make about the setup.
Okay, go ahead.
If the bite stick is not available, then please Velcro the linear accelerometer to the helmet. And in addition, make sure that the head is tight in the helmet to reduce movement within helmet.
Sure.
We have some other comments. We'll make them later.
Okay, and I assume since we don't have any face molds that you want us just to close our eyes, right?
That is correct.
Okay, and Marshall Ops from the Space Lab for the CIC. We got carried away in the dome run a little bit, and we're just getting the gradient IHF gradient sample 302 in, and it's going right now. Apologize for that.
Byron, could you repeat your last transmission, please? I missed it.
Roger, Michael said that we just got the IHF sample 302 going right now. Apologize for that. We're a little bit behind schedule on that one.
I understand. Thank you very much, Brian, that you got 302 started just now. We appreciate that.
Marshall Ops is the 102 PI there.
Repeat who you want to...
If Larry was still there. 2.
Owen, can you hold your comments for him to about 9:20?
Certainly, that's fine.
Space Lab is 201, back on the loop.
And experiment 201 from the Space Lab, PS2, go.
Space Lab, this is 201, do you copy?
Roger, Jim, we read you loud and clear.
Okay, great. Have you, are you doing the setup now?
Roger, we're just getting into it, and the first question I had was, which sensors would you like on us, over?
Well, the only sensors we need are the accelerometer, and you need to use the joystick. I believe you have no goggle. You'll do the experiment with the visor up. EOG is not necessary, respiration is not necessary, BVP is not necessary.
Okay, we copy all that.
Thank you. Space Lab, this is 201, you copy?
Read you loud and clear, go ahead.
Could you tell us when you turn the equipment on?
Okay, we will. And we've got the BRS set up, the helmet's on it, getting out the shoes now, and we're getting ready to go here.
And I believe you do not have a bite stick, do you?
I believe that's correct. We have no bite stick for us.
Then you may stick the accelerometer on the helmet then.
Right.
And Space Lab, we're going to put the master timeline in a temporary hold, and just don't become alarmed.
Okay. Hey, 201 PS2 from Space Lab. We're powering on the equipment right now.
Oh, okay. Fine, yes, we read you. This is 201. We see the equipment being turned on.
Okay, very good.
When you're ready for a checkout, we have a comment to make.
Okay, stand by a little bit yet.
Okay.
Can you all see the data on the ground if we oscillate the accelerometer and joystick now?
We don't see the accelerometer. Have you plugged the accelerometer properly in?
That's affirmative. It's plugged in.
Okay, then give it a movement and we'll see if we see anything on the ground. Just give it a movement and tell us what direction you're moving in, please.
Again, Jim, we're busy up here.
Okay, we're looking at the data.
201, repeat.
We're looking at the data. Are you about to move the accelerometer?
Go ahead. On x-axis, good. Some x-axis.
Fine, we read it fine.
Okay, give me y.
Fine, we read it.
Okay, and z.
We read it, that's fine. Okay, then.
Good. Here's up on the joystick and down.
Fine, we read that.
Good.
Could you give us sidewards on the joystick? What was that, left, right?
Roger.
That was first left, then right. And could you give us up, down once more?
Got it.
Okay, go ahead and start the experiment, and please tell us which FO you're on. Whether you're doing motion, direction, and which axis. Thank you.
Okay, we'll go.
Space Lab, this is 201.
Good.
Are you about to start? We are watching the data. We don't see anything yet.
Oh, we're getting ready to start. Just takes a little longer up here, Jim.
Okay, great. We're just watching. Everything's all right.
Yeah, 201, CS2, we're ready to go here. We're all set up, and this will be first detection of motion in the x-axis. So, Owen, if you'll give him your forward joystick, and that will be detection of motion.
Fine. Go ahead and start. We see the motion. We see the joystick.
And Space Lab Marshal Ops, you go for 5 more minutes on 201.
Byron is 201. We're seeing very good data. If you want to start with the next experiment, detection of direction, you may do so.
Okay, very good. Okay, Owen, this can be... Okay, Jim, you want to go to the next axis here?
Come again? Okay, could you give us one forward motion with the BRS just so we can tell which is forward from backward?
Okay, Okay, here it goes. Yeah, sure. Okay, here it goes. Forward, ready, mark.
Copied. Thank you.
Okay, ready for Y?
Yes, we're ready to Y.
And Space Lab, this is Marshall Ops. You can spend 15 more minutes on linear threshold.
Copy, Bill. Okay, here we are for Y. This is detection of motion now. So give them a forward bump of the joystick, Owen, when you detect motion. Go ahead and mark it. Okay, just push joystick forward. Okay, that will be the mark for detection of motion.
Okay, Byron, I have an update on that time. You can run it to handover.
Okay, Jim, we're going to go ahead and do now direction of motion. So Owen, give them left and right. Okay, and here we go.
Thank you. Byron, this is 201. Can I make a quick comment to you before we lose voice?
Go ahead. Okay.
Yes, in case you have more time during LOS, and I believe you do, please do, after the linear threshold experiment, big movements of the BRS in the X, Y, and Z axes, and ask the subject to note his illusions of pitch and tilt.
Okay, understand.
Okay, thank you. You're doing great.
And Space Lab, this is Marshall Ops. We'll have come for another 40 seconds.
You've been doing a great job, Byron, before we get off the air. Thank you very much.
You're welcome, Jim. No problem. Talk to you later.
Thank you.
And Space Lab, we're going to be doing some troubleshooting on the next CPAC. Be advised.
Space Lab Marshal Ops for 48 minutes and 30 seconds. Good morning from the red team to both the red and the blue teams. We expect this pass to be somewhat broken, and for Bob, Wubo's got some activity on CPAC for you that he'd like to voice up now.
Marshal Ops, this is Space Lab.
Hello, Ulf. We hear you loud and clear. Good morning. And can you, if Bob is there, ask Bob that we're going to replace the activities for CPAC with other activities on CPAC, and we would like Bob to copy that. Over.
Okay. Okay, he's coming on the line.
Thank you.
POCC NS1 is here.
Okay, Bob, if you're ready to copy, then here is a series of instructions on a troubleshooting for CPAC. Over.
Stand by, let me get a book. Wubo, may I take advantage of that opportunity and inform the ground that we have fault 120. And my book says, furnace heating temperature too low for this sample, software port of experiment. And Bion tells me it is in relation to the IHF.
We copied, Ulf. Over.
When you're ready, go CC.
Okay, Bob, first, what we want to do is a Model 5 using checklist S4, which is execution without STL, and it will give you the input for the type command, which is Model 5. T0 is GMT 337/02, column 27, column 00, and the exception time.
Okay, start.
Go.
Break. Break, much slower, Wubo, much slower.
Okay, try again. Execute checklist 4, Model 5, T0337/02, column 27, column 00, exception STL Sierra 02, India 00. Over.
Understand you want me to execute a Model 5 according to checklist page 4, which means without subordinate timeline, it will be at a time of GMT 337/02/2700 with a exception monitor timeline of S02 India Oscar, India 00.
Read back correct, and then you understand, Bob, that is GMT for the input via a type command at checklist 4. Then you have to point the MTV towards the EBA, which is azimuth 229er, co-elevation 9er 5. Over.
Give me the azimuth again.
9er 5. Over.
Understand, azimuth 229, co-elevation 095.
And the next step, Bob, is inhibit of a series of ECAS exception monitors via item 15 and item 16 on the display. Inhibit EBA, PWR, DGP, MTV, and
Break, how about phonetics? Break, how about phonetics?
Using item 15 and item 16 on the display of O2A, we inhibit EBA, Echo Bravo Alpha, PWR, Papa Whiskey Romeo, DGP, Delta Golf Papa, MTV, Mike Tango Victor, and MPD, which is Mike Papa Delta. That's step 3, over.
I understand you want the items. The inhibits there on O2A will be the Echo Bravo Alpha, Bravo Whiskey Romeo, Charlie Golf Papa, Mike Tango Victor, and Mike Papa Delta.
Read back correct, except step 2 is Papa Whiskey Romeo.
Okay, copy, Papa.
And the next one was Delta Golf Papa, over.
Okay, Delta Golf Papa, that makes more sense now, all right.
Right. And also, Bob, I have some PCF changes for you.
Right.
Before FO prep start, PCF 34 to 0.0. 1 minute after...
Start again. Break, start again.
Before FO prep start, PCF 34 to value 0.0.
I understand you want PCF 42 changed to 0.0.
Negative, PCF 34. PCF 34, over.
Okay, 34 goes to 0.0.
Then after 1 minute after prep start, change the same PCF to 16.0, over.
Then 1 minute after FO prep begins, PCF 34 again goes to 16.0.
That's affirmative. And then before you get to T equals 0, we shut down using item 14, all, enter, over.
Okay, and just before T0, we'll do an item 14 all. So we'll never run the actual thing, correct?
That's affirmative.
But we will be able to see the EVA filaments heating up with the MTV, is that correct?
Exactly. If we cannot see it, we could repeat the change of the PCF 34 each minute, going from 0 to 16 and so on.
Okay, you guys gonna be able to see this real time on the ground?
That's affirmative.
Okay, so you want MTV also pumped into the KU downlink, correct?
Just stand by, Bob, and also we have to change the T0 time now, otherwise we don't have enough, so make it 02 hours and 4 or 5 minutes, over.
Okay, copy that.
Space Lab for Ulf, Marshal Ops.
Yeah, go ahead.
Ulf, request to look out the window whether Faust door is open, over.
Okay, you want me to look now? Or what time will the Faust door be open?
It needs to be verified whether it's open now, over.
Okay, let me move to the window.
Space Lab Ulf, correction, FO4 wants to wait for this, they don't want to illuminate the bay. I'm sorry about that.
Okay, no problem. Let me know. Okay, well, I have some information from the blue team. They would like to inform the park that they did the threshold for 201 and both were subjects.
Excellent, Ulf. And also from the blue team, Ulf, do you have from the blue team some...
I'd like to inform you that I treated Madame Rodot's end plates last night with John Perez anti-spreading material, and I would like to rerun Madame Rodot if possible today.
We copied, Ulf. And also, Ulf, if you have some words on from the blue team on the experiment of Larry Young. Over.
Negative. They have left here, but they didn't mention Larry's experiments. I don't know.
Let's leave it like this. Over.
CC, do you want subordinate timeline India or Echo?
Bob, that is India. India, inhibit. Over.
Okay. And PSCC, there's one problem. We were busy with something yesterday, I don't remember what, whether it was the time the ECOS crash or some other thing, maybe the MSTR problem. But anyway, we missed to take a gas sample, and my proposal is to do that today. I checked the PCAP, there's nothing planned to take a gas sample. Maybe you check with the VFI people whether they agree on that.
Roger, Ulf.
POCC, the following happened. I entered the type according to checklist -4, including then the A02A space 00 enter, and I got a depth 17 and an O2A cancel, and now a depth 12 message.
And Bob, this is CPAC. We need to opt the depth.
Okay, my fault.
And we need to turn on the IU too.
And?
We need to turn on the IU.
Didn't catch that. The comm seems kind of ratty this morning. Go ahead, try again.
Okay, this is CPAC. We need to turn on the IU depth.
But IU depth on, but that's step 3 after I do the other things, right?
That's affirmative. And Bob, we need IU depth on now.
Again. CC, say again.
We need the IU depth on now, Bob.
Procedure has me doing it on, turn it on after the 2 types.
We're getting a request here for IU depth on now, Bob.
Didn't understand that, but I turned it on anyway.
That's good, Bob. And Bob, CPAC confirms a good load.
ground. I got a whole series of depth 05s and IO 00s.
Bob, we've got a problem, and we'd like to go back a bit and have the IU depth off. That is OF.
And then start the whole thing over again?
That's affirmed. We've got to start back and try it again. And you'll have to get the other switches also.
I didn't do any other switches in the panel yet.
Okay, very good, Bob. Let's go back and turn the IU depth off and try that sequence one more time.
Give me a new T0 time also?
No, you can use the one you have, and we're ready for IU depth on now.
Stand by. I just removed AO2A, assuming I was going back and starting all over again.
Roger.
So I'm just now running AO2A.
Very good, Bob.
You want IU depth on now or after I do the type messages? Over.
No, let's go ahead and do it before you do the time messages.
Okay, so command, I've run AO2A has been loaded, and now IU depth is going on.
Copy, Bob. Space Lab, this is CPAC for Bob. We're going to have to terminate, Bob. We've got a problem talking to the RAU, apparently.
Okay, I understand it's bigger than both of us, huh?
Yeah, and Bob, what kind of messages did you get, if any, up there?
Basically, this time I'm getting depth 05s and IO 00s.
Roger, copy.
On O2A, which I'm sure you can see as well, it persists with a depth ready no. Some numbers never entered themselves.
And Bob, we'd like to confirm that you knopped the depth. Or off the depth.
Yeah, the depth is operational.
Very good.
Going to knock the depth now, make it non-operational?
No, that's, we're through.
Okay, I'll leave it operational.
That's fine, Bob, and just IU depth off is all we need.
Okay, try again. I'll be around all day.
We appreciate it, Bob. We sure do.
I got no place to go but round and round and round and round.
We'll stick down here, and we're sure working hard. We've had the stuff out all day long looking at it. And the turnoff, I guess, is... The turnoff would be on Delta Tango -14, but I guess you never did get to the place where you turned them on, so we're okay.
No, I turned off the IU depth, and I'm just gonna remove the ECAS now.
Roger.
Space Lab, Marshal Ops for Ulf.
Go ahead, Marshal Ops.
Yes, Ulf, go ahead on the 326. You have from 10:50 till 11:50 for that, over.
Okay, thanks a lot.
And be reminded, Ulf, to get the tribology then on time started, which is about at 11:55, over.
Okay, we'll make sure that goes on time.
And Ulf, just a reminder on that tribology run, there are no thruster inhibits for that run. Do not inhibit the thrusters.
Okay, good enough. Marshal Ops, this is PS1.
Go ahead.
We have a little problem here with our daily planning. Experiment 11, I think I'm supposed to do the vetting and spreading instead of the channel bearing again. Can you confirm that? Because we got message number 61 Alpha, and it says do 11 FO1, which is the channel bearing.
Stand by. That's right. We've got a number of PCAP changes that we need to get up to you now that the loop is clear for that, Ulf, and that's one of the things we wanted to talk about.
Okay, now I'm still confused. You want me to do the journal bearing a second time, is that correct?
That's affirmative. We need a journal bearing run complete from 11:55 to needs to be finished before the maneuver starts at 12:58.
Okay, that's fine. And we do then the vetting and spreading at 13 hours 56 minutes.
That's affirmed. We've also delayed the CPAC charge to clear out that time for you to do it. And
okay.
I will also get with Bob as soon as he's ready to copy some of these changes and make them permanently in your PCAP.
Okay, I'm standing here with the two messages in my hand and was about to start putting them into the PCAP. If you want to walk through them with me, Chuck.
Okay, I can do that. We got about 20 minutes left in this pass, Bob, and we should have good comm for the remainder of it. I'm starting at day 10 on the PCAP, if you can turn to that page.
Day 10, we've been up here that long already?
Now, all it is a change in the minimum ECAS. Shouldn't be important to you at this point, but you got lots of it. It's 5.4.
Okay. Thank you. I can run AOSD and XTLM simultaneously.
At long last. Okay, for hour 12, Bob, relative to the experiment 11 run that we just discussed, the only additional note that we need to add is that you need to wait on the beginning of bearing 1 alpha until the maneuver is complete at 12 hours and 11 minutes.
We're showing 12 hours 15 minutes when it's complete. Is that right or wrong?
Close enough. Just wait till it's done.
Put that in there.
Okay, we had a little handover drop out there for a minute. If your PCAP shows a 13 activity for Ulf about 12:05 or 06, that's been deleted. I don't believe it shows it, but I think it was in once and out on some replanning, and it probably never did make it up to you.
You don't show that.
Okay, the next page, hour 13. At about 13:10 or somewhere in there, we'd like to note a PS lunchtime.
Understand lunchtime about 13:10.
That's firm. Also, in that same area, about 13:10, probably somewhat before that, an ARU and tape change.
Got that.
And can you confirm that you've got lunch period for yourself at a different time?
I was planning on going out to lunch today. I had an invitation, so I was going to go out.
If you find a good place, you might let us know for the future, guys.
Okay.
The CPAC battery charge, which we originally had on during hour 12, has been delayed now to 13 hours 30 minutes for the PS. Space Lab Marshal, did you copy that, Bob? Space Lab Marshal, looks like we've lost a downlink. We'll get back with you as soon as we got it. Space Lab Marshal, looks like we're back for a little while at least, and we still got about 11 minutes. If you copy, Bob, we'll continue with the PCAP updates.
Okay, I'm with you, and let's see, we were probably, forgotten where we were, but I've added in, down here, 102, I've added in the FO2A, as in the teleprinter, and the TV16, and the VITR number 1 changeout, so we can skip all that.
Yeah, what hour were you on at that point?
About 21 hours.
Okay, you got the CPAC battery charge back on 13 and a half, 1330?
Affirmative.
Okay, let me go through here and make sure. I had some notes that came through after those TPR updates, and I want to make sure you got those too. Bob, at hour 19, about 45 minutes, the 321 activity may have a new procedure coming up to you, and we'll watch it and make sure when it does come up, we'll cue you in about the message number.
You're going to shift the 321 down about 20 minutes according to this TPR message, correct?
That's firm, and the heating should begin when we acquire KU coverage at about 1947. And at that point, you'll also have an AV beginning with about 50 minutes on the AV1.
VTR, correct?
Analog video.
Yeah, AV1, right. Right.
Okay.
Okay, we will probably do this, and we'll probably want to try to start this 20 F1 SAL a little early so that we aren't jostling the vehicle, bringing in the SAL stuff while the sample's heating.
Copy that. Also, the AV tape recorder activity can terminate about 20 hours and 7 minutes, and it should have at that time 30 minutes of tape remaining.
Okay, I understand. So it's like going from 47 to 07, correct?
That's affirmed. And you're okay to start the SAL a little early?
Yep.
Okay, we'd like you to look on the PCAP at hour 21.
Got it.
Okay, at 21 hours and 8 minutes, we'd like you to begin AV1 which will have about 55 minutes at that point.
Okay, AV...
Because Ulf will have exchanged and put a fresh tape in by then.
Okay, gotcha. And so 102.2 Alpha will be done on AV1, correct?
That's firm. You are the first. You are the first subject. Ulf is the second.
Okay, any strong preference for that reason?
No, but I can check on it and find out for you.
That doesn't matter.
Okay, also, there's 34 minutes. There will be 34 minutes of tape remaining before you need to exchange the tape. You can refer back to some of the earlier conversations we had on the ground about reasons for tape change-out that affect some downstream tape management, but the message is that there's about 34 minutes worth of upstream pad in that AV1, which you can use as long as you get the tape changed on time at 2140.
Okay, copy that. But AV1, that tape's only going to be there from 2030 to 2130, basically.
What we're showing here, Bob, is 2108 start and 2119 finish. And then another bar at 21 plus 22, off at 21 plus 32.
What I meant was we install a tape on AV1 at about 2030 and then we remove it about 2140.
That's a firm.
Okay. Marshal Ops, this is PS1.
Go ahead.
Okay, let me remind you that we missed to take a gas sample yesterday, and I raised the question whether we could do one today.
Yeah, that's in work, Ulf. We'll have some word for you on that. And Bob, I think that's all the PCAP changes. We've got Mike Haynes on the loop to talk to Ulf if he's listening.
Okay.
Okay, stand by, Ulf.
And Space Lab for Bob, the word from Larry Young on the reason why you are subject 1. If there's a shortage of time, he wants to make sure that we have MS1 on the list.
Oh, you didn't copy that, but okay, it doesn't matter anyway.
Space Lab 300 ops. For off, for Ulf.
Mike, yeah? This is Ulf.
Mike Haynes, standing in for Madame Rodot. I understand you're about to recommence experiment 326, is that correct?
That's correct. I treated Madame Rodot's plate with anti-spreading barrier material, and I'd like to try again.
Okay, I'm sure that's very welcome. 2 words of advice. The film magazine 2415 should still have enough film left, I suspect. And I suggest that you start with the smallest sphere, that is, start at step 4.1 in Madame Rodot's procedure. Start with a 20mm sphere for safety.
Okay.
Space Lab Marshal Ops, LOS in 1 minute. We'll see you again at 11 plus 50. And Space Lab, before we go over the hill, you can expect a metric hammer run in about 15 minutes, just for information.
Thank you.
Spacelab Marshal Ops, AOS for 57 minutes. Spacelab Marshal for Bob. MS-1 Marshal Ops.
Experiment 11, copy.
TSCC.
Go ahead, Bob.
So you just called us.
Yeah, I got a couple things for you. Number one, we're making the assumption that back on day 3 when we got wrapped around the axle, you weren't able to do experiment 25. And based on that assumption, we'd like you to execute that reasonably soon. It'll take about 30 minutes, and it's your option when you do it.
By day 3, you mean yesterday?
Roger.
I did it. Yeah, I got the TV of it, both. This is PS1. I did it this morning.
Okay, that's great.
The kind of updates we like. Keep them coming.
Yeah. Also, Bob, you'll be happy to know that Judy spent the last couple of passes in the Mocha viewing room. Hi from her, and she's listening.
Okay, thank you.
Also, one more for whoever is next up near the orbiter VTR. DMC would like to know what cassette you got in the recorder currently, but there's no rush on that one.
Okay, I'll try to remember that. And we got a 13A cooling message. I don't know if it was just the usual out-of-sync problem or not, but I went through the malfunction, and it's indeed, the cooling's turned off, so there's no problem.
Copy that, thank you. And Spacelab, just a quick question, if you have a minute, as to whether the 300 camera ran on schedule with the cover open.
The 33 camera ran on schedule with the cover open.
That's what I wanted to know. Thank you.
Nice clear day over Tibet.
Copy that.
Marshal Ops, this is the first run for 11. That is the channel bearing 1 without the unbalanced block.
Okay, Ulf, bear in mind we'd like you to wait on the termination of the maneuver before beginning 1 Alpha.
Okay, we did that before we did the maneuver. That is already complete here. That was channel bearing 1 Alpha complete.
Copy that, Ulf, and we'd like a similar cue from you when you begin each subsequent run.
Okay, we better wait. Wait a minute, we can do, the maneuver is 12 for 7, is that right?
Stand by. Looks like 12:15, Ulf. Clarification on that, it looks like it begins at 12:07 and completes at 12:15.
Okay, let me repeat that channel bearing 1 Alpha then another time. We have plenty of film here.
That's great.
Okay, all green lights are on, so we are fine as far as gravity goes. Here comes the experiment run. Strobe light is on. For clarification, we run the camera on 12 frames per second, is that correct?
That's correct, Ulf.
MPOCC, Space Shuttle.
Go ahead.
Either have or just took off tape 15 in the VTR, but that doesn't mean that we've used 15 tapes. It just has to be the number of the tape that's currently in there, over.
The orbiter VTR, is that what you're referring to?
Confirm.
Okay, roger, tape 15, thank you.
But that does not mean we've used 15 tapes. Okay, that was the second run of channel bearing 1A.
Roger. Well, thank you.
And we copy that, Bob.
Hey, John, can you let me know when your maneuver is complete? Thank you. Okay, Marshal Ops, be advised that we are all set for channel bearing 1 Bravo. That is with the unbalanced plug installed. We are waiting for the completion of the maneuver.
Roger, Ulf. Ulf, this is Experiment 11. Since we have plenty of film and we also, these runs are going faster than we had originally thought, I was wondering if you could give us 2 run initiations for each of the remaining modules.
I missed that. Can you say again, please?
All right, this is Experiment 11. Since we have plenty of film and the runs are shorter than we had anticipated, if you could initiate the run switch twice for each module. Do you read me?
You bet, no problem.
All right, thank you.
No problem. I will do that for you.
Thank you, Ulf. Appreciate it.
You're welcome.
Columbia, Houston on air to ground 1. Need you in DAP Bravo now, John. Correction, John, that'd be DAP A1. Thank you.
Thank you, John. Okay. Marshal Ops, this is PS1.
Go ahead, Ulf.
Okay, I'm back to Madame Rodot as long as this maneuver is going on. And I have a 20 millimeter sphere. And I was playing around to find the resonance frequency for it. I think it is about 2 hertz. That's just a number I'd like to relay down before I come back and take some shots of it. It took me an enormous amount of time to set the FPM up because it was left in a real bad mess. It was spilled with oil all over it.
Copy that, and roger the 2 hertz F0.
Yeah, that's amazingly high, but it is also the limit. That's the highest frequency I can do with the FPM. And the amazing thing is I'm using a very small amplitude to excite the oscillation. It's only 0.15 millimeter, and it looks already very, very close to the stability limit of the sphere. It really oscillates.
That's great. And Ulf, Wubo's got a word for Bob, if you think we can do that at this point without disturbing the JB.
Well, Well, there's nothing going on right now with the Shabby because we could resume. Maneuver should be complete. Is it a long story? Thank you, John. Bob, are you upstairs? Yeah, Marshal Ops wants to talk to him. Thank you. Bobo?
Yes, Ulf, go ahead.
Okay, Bob is coming.
Thank you, Ulf.
CC, MS1, go ahead.
Yes, hello, Bob. This is Marshal Ops. I have here some work to do on Experiment 104, which, due to all the trouble yesterday, got slipped away. It is to suggest that you are going to measure a recruitment curve on yourself, also being the operator. And if you're ready, I will explain to you how you can do that. Over.
Okay, meanwhile, we're also this morning getting ready to do some stuff on the CAP, vehicle tour and translation business for the movies, okay? Over.
Okay, Bob, let me ask you then the question, do you think you can operate on 104, let's say from 12 hours 25 until about 13 hours 30, over?
Well, we'll see what we can do. We were going to do the other stuff during that time, but give us procedures and we'll see where we can fit it in.
Okay, Bob. First of all, you just operate according to the normal checklist, being the subject.
One break. Just one quick thing. I'm starting the J1 Bravo now.
And first remark, do not turn on the power until you have a go-ahead that the inverter has been switched. That is an MCC call via the orbiter crew. Second point, the position of the needle in your case is 1 centimeter left, 1/2 centimeter high with respect to the tattoo, plus have a pad for some pressure. Point 3, use the gloves. Point 4, you can position on the triangle grid in front of the life science rack to be able to attach the bungees to about a 1G feeling in your feet. Over.
I understand the location of the needle on the pad and the inverter switch, but say after that.
Use the gloves during the operation, and you can position yourself on the grid for one run of the recruitment curve. If you have some extra time, you could also repeat it, being floating, giving even some more signs. Over.
CC, Space 5.
Go ahead, Bob. This is Marshal Ops.
Marshal Ops, this is PS1.
Go ahead, PS1. This is Marshal Ops.
Columbia, Houston on air-to-ground 1.
Go ahead, Houston.
Roger, John. They're about to run experiment 104 in the back, and before they start that, if you can coordinate with Bob, it's be about 12:30 at the earliest. We need you to turn on the experiment inverter there on panel R7.
Okay.
And we just like you to go ahead and turn that on now, John, I guess, so it'll be ready whenever Bob's ready.
Okay, I'll turn it on.
Thank you, John. And after you get it on, we'd like you to check the experiment DDSs and go ahead and re-op them if it's required.
Okay, I have a green light, and say what?
Roger, I'd like to check on Spec 211, check the experiment DDSs. And
okay, the experiment DDS and re-op is...
Roger, you'll have to re-op those for us, please.
Okay.
Thanks a lot, John.
Want to re-op the subsystem too, or just experiment?
Both of them, John, please.
Space Lab Marshal, just a note for you, the guys here on Experiment 01 are commanding. You can expect to see some depth 05 or message timeout messages or some other ones too, for that matter. Noticed you already got one. Tried to get it up to you earlier, but we had an uplink.
Columbia, over.
Columbia, Houston, go ahead.
Roger. Now on the Spec 211, I've got the SSC opt. The experiment is no opt in the SS column, and experiment is opt in the item 34 is opt, and item 36 is opt, item 30 is opt, but item 33 is no opt, and I did an item 32 and it wouldn't take it. I guess that's because the experiments inverter's got the experiment's computer. Is that not right?
Roger, copy, John. And what we'd like is back in the Space Lab for someone to do a keyboard reset on the subsystem DDS. And that'll clear the NOP on the item 33. And Columbia, Houston, following the reset on the DDS in Space Lab, then you'll have to redo the item 32.
I already did.
Roger, we see that now. Thank you.
Space Lab Marshal, for Ulf, we're showing experiment power off down here. We think it's a problem with our terminal, but we'd like a confirmation that everything is going okay with you.
Are you talking about experiment 11 or okay, loud and clear, Houston? Loud and clear.
Experiment 11, Ulf.
We have the experiment power on. I have 3 low G monitor lights on, so that means that we have power.
Sounds good to us. Thank you.
For your record, I did the journal bearing 1 Bravo 3 times, because when I did it for the first time, I had the impression that the journal bearing did not really spin up. And I thought, well, then I better do it 3 times to make sure that the PI gets good data. And there's one other little thing on the little LED display here, time remaining display. The second digit from the left should read 0, but for some reason it sometimes reads 8. There must be a little electronic glitch in that display.
Copy that.
Okay, we are set for journal bearing Bravo now. Journal bearing 2, correction, journal bearing 2. And it's all set. Here comes the run. Okay, time counter counts 0. Experiment goes to stop. And here comes the calibration. POCC Space Lab.
Go ahead, Bob. This is Marshall Ops.
On this extra 104 run, you want me to do this in front of the life science rack, correct?
Yeah, that is correct, and such that you can do it alone and only need the help of Wolf at the moment you have to get your needle in the knee. Over.
Okay, and how do we connect the bungees?
We thought that it would probably be possible to connect the bungees to the triangle grid floor and adjust them more or less by feeling, such that you have about a 1G feel on your feet. Over.
Okay, we'll look into that. Okay, here comes the second run on shuttle bearing 2. Complete. POCC, you're getting some beautiful metric camera pictures of clouds.
We copy, Bob.
POCC, we'll look into doing this 104, but the first priority is going to be taking the movies because they're already scheduled in the cap.
Roger, Bob, we copied. And one additional point of information, to get it right, you also have to connect the T-handle, which you can just tether it in close by or so. This is necessary for the data to go through the umbilical. Over.
That again, the camera's running.
Space Lab for Bob. For the 104 recruitment, you also have to connect the T-handle just for getting the data through umbilical. Over.
Okay.
Space Lab Marshal for Ulf. Ulf, based on your input relative to the LED indicator, PI feels that he's not happy with the power status and would like you to recycle the experiment 11 power to off and then back on, and of course you'll have to wait an additional 20 minutes after that.
Okay, I'll do that. Power is turned off. Here comes the power. And the time remaining counters counting down.
Okay, Ulf, that's fine. And while you're waiting, we were expecting to see the HTT start at about 10 hours and 40 minutes. Could you just run over and start the HTT, please?
The metric camera is running. I have trouble to read you. Say again.
We would like to have you start HTT, Hotel Tango Tango.
Okay, copy. What time? Right now.
That's a firm.
Okay, we'll do that for you. By the way, what is the vote of the 300 people in respect to that fault 120? 120.
Stand by. Ulf, that's a normal shutdown for the IHF.
Okay. And the grad off lamp is also flashing, so I presume the IHF is also ready for the next sample. Okay, Marshal Ops, the HCT is on again, and I hit the resume at 4 days, 12 hours, 41 minutes.
Roger, Ulf, thank you.
By the way, Marshal Ops, I see on the decap that the daily planning, according to daily planning, I'm supposed to change the AIU tape at 1300 hours. I put a fresh tape in the AIU this morning.
Yeah, that's still on there, Ulf, at about, but it can be done at 1310 or so.
Okay. Repeat my question, Chuck. Is there anything I could do for the IHF?
Ulf, we're working on that standby. Yeah, we'd like you to do a normal shutdown, Ulf, using Foxtrot 600-23. And when that is complete...
Foxtrot 6...
Foxtrot 600-23.
Foxtrot 600-23.
That's affirmative, and when that is complete, you can do a mirror heating facility setup according to schedule.
Okay, thanks a lot.
And Space Lab, Marshal Ops, Ulf and Bob, we are ready to get downlink to Hawaii of TV, real-time TV at 13 hours and 15 minutes. So if you set up a camera for the module looking at your work, that we would appreciate that. Over.
Okay, roger that. It was 13 hours and 25, is that correct?
Negative. Negative 13 hours and 15.
Okay, thanks a lot. Marshal Ops, this is PS1.
Go ahead, Ulf.
Question to the IHF, do we really install the launch locks now?
That's firm, Ulf, yes.
I hope we can reactivate the IHF later in order to process a couple of more samples.
Ulf, that's a negative on the IHF. We happen to have a short circuit in one of the heaters, and therefore we cannot use it anymore. Over.
I didn't understand the reason why we cannot use it anymore.
Ulf, there is a short in one of the heaters. Over.
Oh, I understand, okay. One is really burned out.
Space Lab Marshal, LOS in 1 minute. We'll see you again through Hawaii at 13 plus 16.
Roger.
And Ulf, before we go over the hill, just some additional information. When we had the power problem, they did not get good data on JB2, so you can start with JB2 when you get back to that activity.
Say again?
When you resume the Experiment 11 activity, Ulf, you can begin with bearing JB2. JB2.
Sure, bearing 2, is that correct?
That's affirmed.
Okay, I have 3 already installed. I'd like them to start with 3 and come back.
That's okay, that's fine. Spacelab Marshall through Hawaii for 7 minutes. And Spacelab, if you're ready for real-time TV, we'll switch up a camera if you'll tell us which one you've got aimed. Spacelab Marshall, AOS Hawaii, 6 minutes.
Ocelot, okay, that is Spacelab.
Hello there, Ulf. We're ready for some real-time TV, and if you'll tell us which camera you'd like us to switch on, we'll take a look at you down here.
Okay, take one.
Understand camera 1, Ulf?
All good for you.
Okay, we've got a nice shot of you, Ulf, and we can see you standing right there in the middle of the module.
Okay, I'm done with 11. I did JB3 first, and then repeated channel bearing 2, as the PI wanted me to do, and I hope he's happy now with the power status, but it's a little strange because we have these low-G monitor lights on all the time.
Roger, Ulf, this is experiment 11. That could occur. One thing I'd like to have you look at and be sensitive to when we're running this experiment during the next FO is to look at those LED lights and make sure that they're always zeros, because if there is an 8 that occurs in that, that indicates that we've had a power surge or a power spike that could cause that timer to reset.
Okay, I will take a look. I have the feeling they are somewhat erratic, these LEDs. But as far as the flashlight goes and the camera and the channel bearing, I think we are in good shape.
All right, Roger. The last problem occurred due to the experiment 104 inverter turn-on.
Okay, well, I hope that you will get your science, irrespectively what the LEDs tell us.
All right, Roger, Ulf, and I appreciate your good work on this experiment.
Oh, thanks a lot.
And
okay,
Ulf, you'll be happy to know that we believe Birgit is watching you in real time also.
Oh, that's nice. Okay, I'm back here with the SCM. I have a real nice problem, a very small one this time, because I didn't really dare to inject a lot of oil. But I got the oscillation and also the damping of the free oscillation on film. And I hope Madame Rodel appreciates that. And I'm now ready to increase a little bit the volume and take a little higher risk now.
Okay, Ulf, I'm sure she does also. And could you tell us what frequency steps you went through to work up to the resonant frequency, please?
Okay, I determined the resonance frequency for the 20 millimeter diameter sphere as being 1.95 hertz, 1.905. And I used that frequency for the free oscillation and put the damping on film. I'm a little bit concerned about the Vinton camera because the LED does not really tell me that the film is advancing. So I took the magazine off, marked the film with a felt pen and put it on, ran 10 frames and checked, and the spot with which I had marked had disappeared, so I assume we have an LED problem, but the camera is okay.
Okay, we copy that, and Ulf, we're a minute or so away from LOS. Be advised that the CPAC battery charge scheduled for 13 hours, 30 minutes is not necessary. They're at 100%, and they would prefer not to overcharge. So you have that time clear for you.
Okay, that's great. Then I'll stay with the STM and play around a little more. And I have the feeling that is really the way to do it. The problem we have is that everything is fixed in procedures and things don't obey to the procedure here. And you have a problem. It is much more beneficial to have some free time and try what you can do.
We concur, and you can expect to see us again off at 13 plus 30.
Okay, thanks a lot. If you see big, say hello to her.
Space Lab Marshall through TDRS a little late, but we got you for 49 minutes.
Roger, copy.
And Space Lab Marshall, for whoever is doing the 33 changeout, we'd like you to wait until 19 and 20 are complete, and then remove AOFD before you do the load of 33.
Ocelots, do we again from Space Lab?
Go ahead, Bob.
Say again.
Yeah, 19 and 20 are still in the buffer, and we need to make sure you wait until those are completed, and then also remove AOFD prior to loading the 33 ECAS.
Okay, welcome.
And Space Lab for Ulf, since we got started with the HTT a little bit late, Ulf, you should not do the terminate as per the PCAP, but should wait until you get a flashing ops light for HTT.
Okay, that's okay. POC POCC, assume we want the 3 Bravo Sierra filter put into 33.
Stand by. Bob, we think it should be the same filter. Do you have one in there that's not 3 Bravo Sierra?
I believe, although I didn't put it in, we have the 3 Bravo Foxtrot filter in.
Yeah, no filter change, Bob. We're happy with the 3 Bravo Foxtrot.
Okay, thank you. The magazine is changed out.
Copy that.
Marshal Ops, this is PS1.
Yeah, Space Lab, go ahead, Ulf.
Okay, I have an interesting phenomena here. I'm talking about the Madame Rodin's spheres. If I increase the frequency, the excitation frequency, from low to higher numbers, then I'm unable to cause a resonance phenomena at the same frequency as if I do it the other way around and decrease the excitation frequency. It's a very amazing and striking thing that if I come down from higher frequencies, I'll find the resonance. If I do it from lower frequencies, I do not.
Roger, copied. Ulf, you get a hysteresis there. Very interesting. Thank you.
And Bob, we see you got room for the ECAS now. That's great.
POCC, say again.
Now we see you have room for the ECAS now. Thank you.
Okay. We just got an MMU-09 message, POCC.
Mom called it, Bob.
Okay.
You're really beating us to the punch today.
Space Lab, Marshal Ops for Bob.
You go.
Yeah, Bob, in case Barden didn't tell you, if you have to rotate the knob to slide the magazine cover open a little past the detent with some force. Otherwise, the camera will not start. Over.
I can verify that. And POCC camera checkout's complete.
We copied. Thank you.
Columbia, Houston on air to ground 1.
Head over.
Roger, John, just for your information, we like our configuration with the experiment inverter powered on, and this will avoid unnecessary power transients, and we have plenty of power, so we're going to leave that experiment inverter power on the rest of the flight.
Even for what we were talking about on that message there, over?
That's affirmative, John.
Okay. Yeah, I copy.
Okay, thank you.
Go ahead, over.
Nothing else, John. We're finished.
Okay.
Spacelab Marshall, Experiment 1 is commanding. You can ignore any Depot 5 message timeout messages you might get.
Okay.
And Spacelab Marshall 33 is commanding. Cause those error messages.
Marshall, go ahead. This is Spacelab.
Yeah, the error messages you show on your screen were caused by 33.
Roger. That's a fine. What do you want to do? Should we do anything about them?
Stand by.
Okay.
They're looking at it on the ground, Bob. We'll let you know if there's anything we want you to do. And Bob...
Okay, and I assume that you're...
Go ahead, Bob.
I assume that you can see the magazine remaining now says 526, and the total says 570.
Copy that.
Spacelab, Marshall Ops for Bob.
Go ahead, PSCC.
Yes, Bob. Here we change format in about 2 minutes. So be advised, format 30 is not compatible with 104 if you would get a chance to run it.
Okay, I was looking at the flight plan. It looked to me like maybe from 1630 to 1750 there's a good period of time when I could run it.
Roger, 1630, 1730, and we will make sure here we can make the format such that it will be compatible with the data of 104, over.
Okay, I'll talk to you about that. There's also a period from 1820 to 1920.
Roger, let's first look at the first period, whether we can get the right format, and if so, I will come back on it, over.
Okay.
Spacelab Marshall, we're about 30 seconds from LOS. See you again at 15:05.
Okay. 1, you can enable your thrusters.
Space Lab Marshall, AOS through Tidris for 50 minutes, off.
Okay, Marshall, this is PS1.
Go ahead.
Hey, we have one thing we should talk to you about. In terminating IHF, we had the grad ops light on at the end as we expected. We were waiting for it to go off when we got a stop 1-36, and the grad ops light is now flashing. We tightened the seals, but we did not do the resume or the halt, waiting to see which of those two the ground would rather have us do. Over.
Okay, stand by, Bob. We'll get an answer.
And we also have another 13A cooling on message.
Roger, 13A cooling on. Space Lab Marshall, can you guys tell us whether the launch locks are in?
The launch lock is in on the port 2.
Copy.
And the comment from the front cockpit ground is that we're trying to do airglow photography, but basically we have light all the time these days.
Copy, Bob. We understand.
And Space Lab for Bob, just ignore the message 13 Alpha cooling. Over.
Space Lab Marshall, we'd like you to do a halt, Hotel Lima Tango, IHF 31, enter.
Okay, a halt, IHF, enter.
Negative.
Halt 31. Halt 31.
Halt IHF 31, enter.
Roger. Roger. Marshall Ops, this is Space Lab.
Go ahead, Ulf.
Okay, for the wedding and starting experiment on Module 3, we lost one of these little mirrors. We are trying to fix it, but it will take a little while.
Okay, Ulf, thank you. Space Lab Marshall, we've got a DDU thing for you to do for us, please. Whoever's close.
Say again, POCC.
Bob, we noticed we're about to go into the SAA, and we would like to have the high voltage turned off on experiment 17. On experiment 17. That's stand by. Yeah, 23, Bob. Experiment 23. It's something that was planned to be done, but somehow it didn't show up in the software. So we'd like you to go to PTC, Payload Thermal Control, issue an item 17 to turn off the high voltage.
Okay, it's done.
Thank you. Space Lab Marshal, oh, you guys are busy with the little mirror problem, but we have an urgent request from 300 ops for a status on the IHF, please.
IHF has been turned off.
Okay, and then we assume that the mirror heating facility is being set up then.
Affirmative.
That's great. Thank you, Bob. Space Lab Marshal Ops for OLF, no response necessary, OLF, but before you power down the tribology experiment, we'd like to talk to you a little bit about leaving it on for the duration in order to keep the low G lights in operation, and no hurry on that. We can talk to you when you're ready.
Roger. Marshal Ops, this is Space Lab.
Loud and clear, Off. Go ahead.
Okay, I'm done with Module 3 for the vetting and spreading. We lost a little time because we had trouble with that mirror. And I noticed that there was no oil coming out of all these things. I don't really understand why that happened, but that's unfortunately the case. All the others worked nice, and by the way, when I did the others, I always hit the experiment run switch twice to fill the orifices entirely with oil. But when I did Module 3, I stick to the procedure and did it only once, and maybe that is the reason why there is no oil spreading over the front surfaces now.
Okay, Alf, that's probably right. Usually we have to hit that a couple of times to fill that so that we make sure that we get it, the oil dispensed properly. Can you rerun Module 3 now, or have you been able to get that mirror placed back on it?
Okay, we had that mirror on for the run. It is gone again, but I can try another time, and I think that's probably the best idea, just to try another time.
All right, you have not run Module 4 yet, is that correct?
Lab Marshall. Know you guys are busy with the little mirror problem, but we have an urgent request from 300 ops for a status on the IHF, please. Space Lab Marshall ops for Ulf, no response necessary, Ulf, but before you power down the tribology experiment, we'd like to talk to you a little bit about leaving it on for the duration in order to keep the low G lights in operation, and no hurry on that. We can talk to you when you're ready. Roger. Loud, this is Space Lab. Loud and clear, Ulf, go ahead. Okay, I'm done with module 3 for the bedding and spreading. We lost a little time because we had a trouble with that mirror. And I noticed that there was no oil coming out of all these things. I don't really understand why that happened, but that's unfortunately the case. All the others worked nice, and by the way, when I did the others, I always hit the experiment run switch twice to fill the orifices entirely with oil. But when I did module 3, I stick to the procedure and did it only once, and maybe that is the reason why there is no oil spreading over the front surfaces now. Okay, Ulf, that's probably right. Usually we have to hit that a couple of times to fill that so that we make sure that we get it, the oil dispensed properly. Can you rerun Module 3 now, or have you been able to get that mirror placed back on it? Okay, we had the mirror on for the run. It is gone again, but I can try another time, and I think that's probably the best idea, just to try another time. All right, you have not run Module 4 yet, is that correct? Not yet. Okay, well, if it looks like it's going to take a while to get that mirror repaired on 3, I'd like to go on ahead and at least get Module 4 completed. Okay. How come you can enable for a short while, but I'd like to get it back one more time. All right, fine. I appreciate that. Oh.
Space Lab, Marshal Ops for Bob. Yes, Bob, two things. First, experiment 33 has some problems, and it's supposed to be started around 1540 automatically. We would like you to have a look at the black and white discs on the side of the film transport and see whether the film does transport. Over.
Okay, let me check and see if the film transports at 1540.
That's correct, 1540 or 1542, whenever the timer is started automatically by the timeline.
Okay.
Also, Bob, for your information, for 104, if you would like to do that starting, let's say, around 1640, at 1705, the format is correct to downlink the data. 1705 till 1725. Over.
Okay, we'll try and fit it in there.
And also, Bob, the 33 PI asks you to do a timer stop if the disk does not rotate after a while.
That last again.
If the disk of experiment 33 does not rotate after the timer start has been given by timeline, please give a timer stop. Over.
Okay, the timer stop, all right. John, can you inhibit your process? Thank you. This is CS1.
Marshal Ops, go ahead, Ulf.
Okay, we have data problem with the MSCR. The whole CCO display field is filled with numbers, basically zeros, and we have an SIU data fault and message fault. Two live zones.
We copied, Ulf.
Meanwhile, let me tell you the following. 11 is running, and I successfully did two spheres for Madame Rodel, but then I was running out of film, and when I tried to redo the whole thing, the liquid spilled over during the oscillation. When the sphere is compressed, such that it forms the disc during the oscillation, then the contact angle becomes large, and that was the problem again. It spilled over the edge of the small support end plate, the opposite end plate. So I gave up for the time being on Madame Rodel, but maybe I can come back and do it with plunger.
Roger, and Ulf or Bob, are the black and white discs turning of the film transport of 33? Over.
Negative. The vacuum motor came on, but there was no sign of no noise of release, nor did the take-up and supply reels move.
Okay, we expect a film jam in that case, Bob, and please make a timer stop. Over.
We did that.
Thank you.
And is there anything we can do about the film jam there, CLCC?
Yes, Bob, stand by. We discussing it. Over.
Right.
Space Lab Marshal for Bob.
To go?
We'd
like you to try a single film release, Bob.
Okay, just the manual one off the remote control unit, right?
That's affirmative.
Space Lab, martial ops for Ulf.
Yeah, using the motor switch.
Again?
Yes, Ulf. First, you have a lot of noise on your comm. Second, can you give us a reading again of the CCO display of the MSTR, and also check whether RAW 14 is up? Over.
Okay, let me check the RAW first. RAW 14 is up as far as the DPN page tells.
Roger.
Okay, PO3C, when I went to release, nothing happened, and then when I went back to standby auto, the whole thing went off.
We copy that, Bob.
Okay, now, what do you want me to read down? Do you want 8 lines of the CCU?
That's affirmative.
Of the CCO, sorry.
That's affirmative.
Okay, just a second, stand by. Turn gun. Okay, I'm done. You can re-enable everything. Thanks a lot. Okay, well, we did it with that. No problem. Okay, move on. Are you ready to copy?
Ready to copy.
Okay, first line called input echo. First character is blank, second is blank, then 0,